Okay, today we talked for a little bit about forces. So, a force, it's just a push or a pull on an object. Okay, if we're going to do the nice formal definition, it's an interaction between an object and an agent. Let me give you an example. If you were to put a force on a table, okay, so think of our lab tables. You are the agent. You are the one putting the force on the object, which is the table, okay? Forces are vectors, meaning that the direction is very important, okay? The variable we're going to use for force is just capital F, and the unit, okay, is newtons. Oops. Okay, so this is named after Sir Isaac Newton. We'll talk a little bit about him on Monday, so don't worry all about that. But that is what's going after your numbers. Okay, so some examples of forces. Okay, let's just make a quick chart here. Agent and interaction. Okay, the big one that we've talked about already is gravity. Gravity is a force. We're going to do it Fg for force of gravity. Okay, agent, the thing causing gravity is the Earth. Okay, other ones, okay, that we've talked about, you got air resistance. Okay, and that is Fd for drag. That's caused by air. Okay, some other big ones that you might have heard, electrostatic. And that is Fe. Okay, that's caused by charged particles. So from chemistry, right, electrons are repelling, protons repel each other, electrons attract protons. So charged particles, that is the electrostatic force. Magnets also are forces, right? Okay, give us our magnetic force. Okay, we call it Fb. Okay, we'll get to why in a couple months. Other ones, applied force. So Fa. And that's called by humans. So when I said earlier, you pushing a table, okay, that is the applied force. Other big ones we need to know, tension. That comes from a string or a rope. Okay. Friction. FF for friction. Friction's caused by a surface. Okay, so most of the time it's the ground, but it could be any sort of surface. Okay. The surface also causes another force called the normal force. Okay, so Fn. Both of these are caused by the ground. Friction is always, always, always parallel to the surface. Normal force is always perpendicular. So normal in math class means perpendicular, so the normal force is perpendicular. Okay. We will talk more about what that is on Monday, but make sure you have that in your notes. Other thing about friction, it always opposes motion. So if the velocity is to the right, okay, friction's to the left. One more, the spring force. Okay, that's Fs, just for spring. Another thing we'll get to, okay, on Monday. I am going to star a couple. So Earth, okay, magnets and charged particles. Besides these, okay, forces have to actually be physically touching your object in order to put a force on it. So for the applied force, if there's not something touching the object, there cannot be an applied force. Okay, gravity, electrostatic, and magnetic forces are a little bit different. Okay, they can act at a distance. So even when you're not touching the Earth, there's still gravity acting on you. Okay. Now, what we learned to draw today is something called a free body diagram. And what it is, it's a representation of the forces acting on an object. Okay, so let's talk about somebody just standing on the ground. Okay. First thing, the force acting on them is gravity for sure. Okay. You also have a normal force. Normal forces come from the ground itself, and because the person's standing on the ground is pushing up on them. Okay. So to make a free body diagram, you're going to draw a dot to represent your object. Okay. Then you're going to draw the forces in. Forces are vectors. Vectors we draw as arrows, so therefore you're going to draw arrows. Gravity. Gravity always points directly downward. So this is the force of gravity. Normal. Normal pushes up on the person. So this right here is the free body diagram for the person. Okay, let's do another example. Let's say that there's a box hanging, okay, from a string right here. Forces acting on it. Force of gravity, okay, and force tension from this string right here, okay. So gravity goes down, okay. Tension, which way is the string pulling the box? It is pulling the box up. So that is the way tension is acting. That right there is our free body diagram. Let's do another example. Let's say a box is sliding, okay, down a ramp. Let's say there's no friction. Make it nice and easy. Okay. We have gravity goes always directly downward, and normal. Normal goes perpendicular to my surface. So if this is my surface, perpendicular is in this direction. So normal force goes like that. One more example. Let's have that same box, but now there is friction. So, gravity, normal, and friction opposes motion, and it's parallel to my surface. So if my surface is going this way, so is friction. So friction's going to go like that. Okay, your homework is to do these free body diagrams. Take a look at them and try them. Again, we'll go through them when we get back to school.